Today's talk is going to be an introduction to Git. So for those of you using Git today already, this talk will show you a little bit better the sort of the internals and how to think about Git as a different version control system than what you probably have used before Git. And for those of you that are new at it, it's sort of an introduction. So hopefully this will help you ease into it if you want to start using it. So those of you that did raise your hands for the Eclipse thing, the Eclipse Foundation is moving most of their projects to Git. So Eclipse itself will be using Git primarily for most or all of its projects in the next couple of years. And there's been a lot of work done on eGit. I'm not going to be showing any Eclipse stuff, any really Java-specific stuff. It's just going to be command line stuff. But if you use a GUI or if you use a plugin or something, most of the concept should transfer over fairly well. So this is the introduction to Git. OK, so real fast, let me introduce myself so you kind of know why I'm up here and give you some resources, some takeaways from this talk. Since I'm going to be speaking, I tend to speak fairly quickly. So unless you're a really good note taker or something, if you want to go back and reference what I've been talking about, I'll give you some resources. So my name is Scott Chacon. I work at GitHub. Has anybody been to GitHub? OK, about half. Cool. So it is a source code hosting site. So if you have a Git project, a source code software project in Git, you can push it to GitHub, and we'll host it for you for free if it's open source. If we do like paid private stuff is how we make our living. But I've been there for about 3 years now. I also did this site. This is the official Git website. So if you go to gitscm.com, this is where you'll go to download Git for Windows or for Mac, or get the source code for Git if you'd like to. There's links to documentation. There's a documentation tab, things like that. So this might be really useful to you if you want to install Git going forward. You're not using Eclipse, and you just want it in the command line, or find some documentation or something. There's another site that I did called Git reference site, so gitref.org. All the stuff I'm going to be talking about today is on this website, sort of the shorthand. This is sort of the reference material for the stuff that I'm covering today. So it's not everything that you can do in Git. It is the most used options for the most common commands that you're going to be using. And it sort of groups them by what you do with the verbs, right? So some of the verbs go in more than one section. But if you want to figure out how to do branching and merging, those are the 5 commands that you're probably going to be using and the most common options to those commands. Finally, this is a book that I wrote, Pro-Git, which was published by A-Press. They were kind enough to let me Creative Commons license this, so you can read it online for free. It looks like this. You can read the entire book online. You can download PDF or Mobi or EPUB or whatever. I believe we have all of those available, and if you want to read it on your iPad or something like that. But this is a full book that is free. You can even get the markdown source for it if you want to translate it, or it's available in a bunch of different languages as well. But if you need it in another language, then you probably won't understand what I'm saying. So this is my email address. If you have any questions, feel free to contact me. You can say Java Talk or something, and what your question is. You talked about this, whatever. I'd like some more information on that. More than happy to answer your questions. Some people prefer to ask questions over Twitter. That's my handle on Twitter as well. All right, so that's more than enough about me. Some leave-behinds for you. From here on out, you're on your own. I'm not going to pause for you to take notes. But if you do have questions, please do raise your hand. I'm more than happy to answer questions in the middle of the talk if something is unclear or you want more details on something. And if I don't feel that it's relevant, I won't answer it. OK, so what is Git? So Git is an open source distributed version control system designed for speed and efficiency. So that is the sort of official line of Git, right? But there's a couple important things in here. One, it's open source. So you can go, it's like any other open source version control system. It's GPL'd. You can download all of the source code. It is very kernel hacker-y. It was written to manage the Linux kernel, so it's kind of difficult to understand in some ways. It's a big monolithic C database or source code. But you can go on the website. The icon's a little bit different now. It looks like a little penguin. But you can download the source code, open it up, see what's going on if you really want to do that. It's a distributed version control system. So how many of you use a distributed version control system that is not Git? Has anybody used anything else, Mercurial or Bazaar, possibly? OK, just a handful of you. So it's a distributed version control system. So this is a different class of version control system, and it has some implications to it being distributed. So in a centralized version control system, which is what you have probably been using, what most of you, how many of you don't use a version control system at all? I'm just kidding. I'm not going to make you raise your hands. In a centralized version control system, so in Perforce or in Subversion or does anybody use anything other than Perforce or Subversion? Clear case? Anything else? Mercurial. Okay. So in a centralized version control system, in Perforce, in Subversion, in ClearCase, what tends to happen is you have a database on one server, on one system somewhere, and that's your server database. And there's a clear differentiation between the roles of the client and the server. And the clients tell the server, I would like to start working on this project, and they download a snapshot of that project, whatever the latest one is, and they can start working on that, and they can check in incremental changes of some sort to say, here's an update, here's a way of making this code base better. And Computer B does the same thing and probably gets it at a different point, but they have to operate through this central server. The entire database lives on this server. If you lose this central server and you don't have a backup of it, you're screwed. There's basically nothing that you can do. You have maybe some of the later snapshots, but that's about it. Sometimes it's even difficult to recover them in cases of things like ClearCase. Git distributed version control systems are different. So what distributed version control systems mean is you don't check out a version of a project and start working on it. You clone it. Usually the verb is clone. Git clone, you give it a URL to clone. And what clone means is clone. It means take every bit that's on the server right now, copy it to my local hard drive, and let me start working on the database locally. So you don't have to be online for most operations. It tends to be very fast because you're just operating in your local file system. There's no network latency overhead to deal with. If the central server goes down, everyone has a copy of the database. You can do backups you can have a database on a central server, on some server that everyone has access to, but it doesn't mean that it's any different than any other node in the network, right? You can push and pull directly to peers, and you can push and pull to a central server, and it really does not care which one of those you do. Yeah?
In this case, one is designated as the central server. If that was to go away, could one of the others become the central server?
There's a couple different options. So yes, you could. That tends not to be what you want to do because most of these are personal on laptops and things like that. I only mean central server in that that's what everybody has write access to in order to collaborate, or read access to in order to collaborate. And so that's a central point for people to synchronize their work, right? It's not special really, except that they have it as an alias in their local profile. So if that goes away, you can either put up another system that everybody has SSH access to or something, and take any of these databases and put it there, and then have everybody redirect to that, and that's fine. You could designate one of them, but unless it's permanent, semi-permanent, then people are going to have to keep changing their aliases. But yes, as far as Git cares, all it needs is another database that is similar to the project, right? So it is a fully distributed system. Just about every operation except synchronized. So what you do is you get a copy of the database, you write new snapshots, new commits to that local database, and then you synchronize it with other ones. And so if you have a centralized one, everybody synchronizes to the same point and make sure that everybody's sort of in sync at the time of pushing or pulling, right? At the time of synchronizing those databases. So other than that, everything is local. There's a couple of different implications. One is almost everything is very fast, right? If you're running a Git log, if you're running a log of the file system or seeing a log of a file, what is the history of this file or the history of this project or branch or something, it's just reading data out of your local database. So it's really, really fast, right? If you're doing a diff, it's just doing it off your local database. You do not have to, you can do it on an airplane, you can do it offline, you can do it off VPN, which is really important, right? You don't need network access to any other system in order to do just about everything. So it's very fast. It means every clone's a backup. It's really difficult to lose a system entirely, right? Everyone working on the project has, in some state, a backup of the system. And you can work offline or off VPN, right? If you get on the train, you get on an airplane, you don't need network access for almost everything that you do in version control. It's only when you push, when you pull, that you actually need to access the network. There's no way of getting around that. Everything else is local. So you don't need a network to do all of these things, to merge branches, right? To commit changes, to get other revisions of a file, to compare to some older point in the database. You don't need the network for any of that stuff. Sure, yeah, you can set up a local repository. You can have a remote, which is just another version of the database it knows about. You can clone your own repository to another one on your file system and push and pull to that if you want to. And you can do pushes and pulls over file://URL, and that works just almost exactly the same. It uses the same mechanisms as going over HTTP, over SSH, or any of the other protocols that Git will allow. So if you want to test stuff out, you can certainly just clone your repository somewhere else in your file system and add that as a remote and push and pull to see what's going to happen. But it's also very easy to just create something on GitHub or any of the free hosts and play around with open repositories. Yeah.
What database does it use locally?
It uses its own proprietary database. The Git database is its own. But it is very easy to inspect. And I'll show you some tools on how to do that if you want to look in the database, if you'd like to do that. So, okay, so it's immutable. So you will hear at some point in working with Git, if you get into it at all, about rewriting history. How many people have heard rewriting history in terms of Git? So Git does not rewrite history. There's no command in Git that will rewrite your history. What Git does, when you do something that is called rewriting history, when you do an amended commit, or when you do a rebase or something like that, which I won't really be going over those, but if you get to that, what Git is doing is it's writing a new history and then moving a pointer, right? And so if you delete a branch, you're not deleting the work in the branch, you're deleting the pointer, but the data all stays in your database. If you rewrite your history, you're not losing the old history, you're simply losing the pointer to it, right? You write an alternate history and then move a pointer over. And so if you want to get it back, you can either drop a pointer there, and I'll get branching is really just pointers. You can either drop a pointer there, or you can go through a log. Git keeps a log of everything you've been doing, so you can always go back. It's very difficult to lose data in Git once you've committed it, right? If you write git commit, you can always rewrite that history differently, but it's very difficult to lose the data itself, right? It keeps it around for a long time. When you clone, when you actually push data over the network, it only pushes stuff that's reachable. So you can do, when I'm saying rewrite, it rewrites it locally, right? When you push, you can you can delete it on the server and then just push a new one, right? With only the stuff that you want that's reachable. The stuff that's invisible through normal commands will not be pushed over the network. So you can easily do that. It's a difference of changing the sort of pointers around and then wiping it out and starting over, right? And it's actually not that difficult to do. Okay, so the final thing that's sort of a big mind change is if you're comfortable with version control and it's a version control system that is not Git, you're going to hate Git. You will hate it. When you start using it, you will hate it because it is very different. In the way that it thinks about version control, it is very, very different than Subversion or Perforce or systems that have been around for a very, very long time. And so they're in the backs of our brains at all time as this is how I do version control because it's the only way that you could do it for the last 20 years, basically, right? From RCS till now, it's been basically the same system, right? Subversion and Perforce are alternates of RCS. They still work basically the same. They still think about their data in basically the same way. So Git does not. And so I want to try and give you an idea of how Git differs and how it actually internally thinks about its data. Because if you think about it this way when you're using Git, I think you'll get a lot less frustrated. The easiest thing to learn Git and to like it is to completely forget about version control as you've been doing it and try and rethink it in the terms of Git, right? Think about it differently when you're using Git. Don't try and think of how would I do in Git what I used to do in Perforce when I want to do this. Try to think about it in these terms instead. So most other version control systems are file-based Delta storage systems. So what happens is you have a couple of files. I'm trying to go through this kind of fast. When you add a file, when you say git or svn add readme, svn add hello, or whatever system you're using, what those systems do is they create a log for each file. It is file-based, right? It's file-centered. So it creates a log for each file, and it puts some version in the file log. When you change something, if I change a string in this file and I commit, it will save a delta in some manner. Sometimes sometimes it keeps the latest version and then deltas backwards. It depends on the system, but it adds some version to the log of that particular file, right? So you have version 2 of hello, and you still have version 1 of readme. If you rename the file, this is where it gets hinky, because you have a log of the file, but you still want the history of the file, right? So what you need to do is you create a new log, and you have some pointer that points back to the older file. This is what it used to be called. So you have these sort of explicit renames. It says this is what the file used to be called. So if you're traversing the history, you have to jump over to this log and then go backwards from there, because that's what it was called. And so on and so forth, right? So it just, for every snapshot that you have, for commit D, it has to go through and do some amount of calculation to figure out what the snapshot was by the versions of each log that are reachable in that commit. Does that make sense? Is that how you think about version control, out of curiosity? Some people do, some people don't. This is how Subversion thinks about it, right? This is how the system itself thinks about this data. And some people have carried that over. It depends. Git does not think about data this way, right? Git thinks about data as snapshots. So when you say git add, it is not adding files to, like, creating a new log. It's not saying, I want to add this file to my version control system. When you say git add, it says, I want to add the content in this file to my next commit. So you run it every time. If you change a file, you run git add on it again, because it's not saying it's the first time I've seen this file. It's not adding new files. This confuses some people. It's saying the content that's in my working directory right now for this file, I want that to be in my next snapshot, right? So it's a different usage of add. So that's confusing sometimes. But what it does is it takes the content of that file. It ignores the file name. It just takes the content. It checksums it with a SHA-1 hash. It puts that content in its database, in a key value store, basically, and then it gives you back as the key the SHA, the checksum of the content, right? And says, if you ask me for this SHA, I will now give you back this content. Does that make sense? And it does that with hello. When you say git add hello.c, it does that again. When you say git commit, what it does is it records a manifest, and it calls it a tree object, but it records a manifest that says, it's sort of like a directory listing. How many of you are familiar with POSIX? Like POSIX systems, POSIX inodes and directory listings and stuff. So this is very similar, right? This is sort of based on that. So you have this directory listing that says, here's this content, right? And here's what the file names are for all of these. And it checksums that and gives you a checksum back for that. That's a key for that as well. So if you ask it for that checksum, it gives you that manifest back, right, the directory listing. And that's recursive, so there's trees that point to other trees and stuff. And then you have a commit that has your message, my initial commit, your username, your email address, the dates that this happened, and then a pointer to one tree, to the root tree, right? And it says this is the manifest for this commit. This is exactly what it looked like. And everything is checksummed. So you can't change any data in Git without changing the way that you pull the data out of Git, which means it's cryptographically secure, right? Everything you get out of Git is the exact same bits you put in, because the way that you access it is by the checksums. Does that make sense? So this is the README file. If you say, when it's checking it back out, it says, if I ask it for C3D, blah, 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 it's a big 40-character hash, it will give me back whatever that value is, whatever that content is. And if you ask it for this is the content for hello, it gives you back that content. Now, if we change the file like we did in the previous version, in the previous system, it sees different content, right? It checksums differently. It does not look at that file. It doesn't have a log for that file. It just sees new content that it has not existed in its system before, puts that content in, gives you a SHA back. When you run git commit, it gives you back a new manifest that simply points to a different, points to the same README, so it's sort of like a hard link, right? It's like reusing the block pointer. So it points to the same content for the README, different content for hello, right? There's no history of hello unless I walk through these and compare manifest to manifest to see what changed from one to the other. And there's also a pointer from commit B to commit A. It points to the one it was based on, right? So you can get a diff, what was introduced, by comparing the manifest that each one points to. If you rename, so this is where it gets kind of interesting. If you rename the file and you run git commit, no new content is added to the system because you didn't modify any files, right? There's no new content that exists on your system. All you did was change a file name. And so what it does is it puts it in and it just reuses the same pointers, the same SHAs, the same checksums for the content, right? It says these are exactly the same things, they're just under different file names. Git does not store explicit rename information. The way that Git figures out that you renamed a file is by looking from one commit to its parent and saying what files disappeared in one and appeared in the other and are content similar, right? And it's a heuristic. It's 50% is what the default is. You can change it. You can say assume renames are 30% similar is a rename file, or assume it harder, assume it's 70%. So yeah. If you look at this, there's a lot of waste, right? These two files are stored fully. The reason why is because it's very fast to write it that way. You don't have to, Git does not have to figure out the delta compression while you're writing the file to disk. So it stores it this way initially. When you push it over the network, what it will do is delta compress these files against each other. But it doesn't necessarily have to delta compress a file to another version of the same file. It can delta compress any content to any other content in the system, right? However, it gets the best delta compression. And you can say, Git, take more time and make me a smaller pack file. Do more delta compression on this. Make a longer delta chain. Take more time to figure out how to get the most savings out of this. And it's very, very good at it for text-based files. And then if we change this or something and we say copy the file this time, right? It puts new content that it sees in, puts in a new manifest. And interestingly, if we copy a file and add it back in, it will simply use the same block pointer for both, right? So it uses sort of hard links within the trees. And also interestingly, if you recursively copy a directory, these point to sub-trees. So if you recursively copy a directory and you don't change any of the files in that directory, it will hard link directory structures, which POSIX won't do, right? But this can. So anyways, this is how almost every centralized version control system thinks about its data, and this is how Git thinks about its data. And I think this is much simpler, right? What they did is a very simple database, a very simple structure, and then complex algorithms to do interesting things with that, right? But this file structure has not changed since 1.0. I mean, it hasn't changed for 3 years probably in almost any way. You can still read old file systems that were done several, at almost the very beginning of Git, because it just really hasn't changed very much. Just the way that it works with this data has changed. Okay, so what I want to do real fast, so I have some pretty pictures and stuff like that, but what I think I want to do is deviate from the slideshow a little bit and just show you an example of using Git on the command line, okay? Because I think it's interesting. Ignore my friend. All right, so I'm sorry, I have to do this. I'm a Ruby guy. I'm not a Java guy, I just know Ruby. So create a little Rails app. Okay, so here's my little Rails app that I just made, right? So let's say that we want to do some development on this. I kind of want to show how Git's cool. So this is not a Git repository yet, right? One of the interesting things about Git is that you can use it. You don't have to have extra nodes. You don't have to have a server in order to have a local database, right? You can use it like, has anybody used RCS? Cool, the cool people have. So you can use Git like you used RCS. Can everybody see this? Is this okay? So you want me to make it bigger? Is that any better? So you can use Git like you used RCS. So you can say git init, and you have a Git repository. This is how Git repositories are created initially, and then you push them up to a server somewhere, or you can initialize them around on the server if you want to, but that's fairly rare. So you create a new repository, git init, I have a repository now. If I say git status, I can see all of these files are, actually let me, this is hard to see, I think. That's easier to read? So I have all these files, right, that Rails generated for me. So I can say git add dot, that adds everything to my system. I can say git status again, it says here's all the files that are new, and I can say git commit, and right. So it's fairly simple, right? So I've just done a commit. If I say git log, I can see that I have one commit. And I was telling somebody before that you can actually, well, I'll get to that in a second. Okay, so this is my commit, right? Now, let's say that I want to do something. So in Git has a very nice branching system. So I want to show you the branching system real fast. So if you say git checkout -b, checkout switches branches. So it's sort of like SVN switch. You say git checkout -b blue. And let's say that I go in here. And I want to change my background. Let's see, RGB. Okay, so now I have let's be honest, a beautiful blue background color, right? So now if I say, sorry, stop, I'm going to stop doing that. That's an alias that I have. If I say git status, that's an alias for git status -s. If I say git status, it will say, here's the file that you've modified, right? If I say git commit right now, it's not going to do anything because I have to say git add. I have to say add this changed content to my next commit. So I'm going to say git add public, and then if I say git status, it gives it to me in green, and I can say git commit blue background. Okay, so you can see that if I run git branch, I'm on my blue branch, right? I said checkout -b blue, that created the branch and switched me to it, so now I'm on my blue branch. If I say git checkout master, then it reverts the files in my working directory, right? So when you switch branches, it modifies your working directory. So if you add files or something, it will, and you commit them in a branch and you switch to another branch, it will remove it from your working directory, right? And it'll go back and forth. So you can't switch branches unless your working directory is clean. There's a command called git stash to clean it in the meantime, and then you can make it dirty again with those. It sort of does saves a patch of everything that you've done and then allows you to apply it later. But using Git effectively assumes that you're going to use one working directory for all of your branches. You're not going to have separate working directories for multiple branches, right? You do everything in one and you fast context switch between them. So now if I say I'm on my master branch now, git checkout -b, think of something else we could do, email, and I go in here, you can see that this was reverted, right? That's not the blue color anymore. And so I go in here and I do something silly. Let's see. I'll take this and I'll put in my email address into the little sidebar here. You can use git diff to see what you've done. I can see that I added that. I can look at the website. I've added my email address in the sidebar there. There's a little shortcut you can do so you don't have to run git add on everything. You can say git -a. Git commit -a will automatically run git add on everything you have modified that was in your last commit, not untracked files. So it's very similar to svn commit in what files it decides to stage. Oops. And now I can switch back and forth. Git checkout blue, I get my blue background but no email address. I get my email address but no blue background. So I can switch back and forth between the different contexts I'm working in. And I can share these with people and people can work on them separate, right? So you don't have to do, it's very uncommon for people that are using Git as a team to use things like feature flags, right? Because you don't have to commit everything to trunk, right? It's very easy to create branches and work on them independently and merge them in later. So now, if I wanted to move them together, right? Let's check out master, where I have neither of them. I can say git merge email, and I get my email, git merge blue, and I get my email address and my blue background, right? So I can merge the context together fairly easily. And Git is very smart about doing merges well and not giving you conflicts all the time. In fact, an interesting thing that I can do, so I don't know how many of you did, yes. So rebase is a little bit more complex than this intro. I recommend fetch and then merge manually rather than pull, but I'll get to that if I actually get to that point in the presentation a little bit later. But rebase, I would almost always, if you're doing it within a corporate environment, I would almost always recommend using merge over rebase in basically every instance. Personally. But we can talk about that afterwards in more specific detail if you'd like to. So now I can actually go back to my blue context, and you can see that it took my email address away when I switched back to blue, right? Because I left that context back there. I only merged them both into master. When you do a merge, it only affects the context you're currently in, right? So you can always go back. So interestingly, what I can do is I can go back and I can change this color again. So let's do something even prettier. And then I can go back to my master branch and merge in the blue branch again, right? And so now I get the prettier blue color with my email address, right? And so you can do reintegration merges. So if anybody's ever tried to merge a branch in Subversion into trunk more than one time, like merge it and then go back and do more work on it and then merge it again. Has anybody done that? No, because you've committed suicide, right? You're not in this room, right? So it's very easy to do in Git, and that's actually a really powerful tool. It's a really powerful tool to be able to do that because what it allows you to do is the following scenario. Say you're running on MySQL and you want to switch to Postgres or something like that, right? You have to go through, or even better, you want to internationalize your site. So you have to go through all your view code and you have to change everything, right? Every damn string in your whole thing you have to put some wrapper around. So if you're working on that, and it takes you a really long time to do, and other people are working at the same time on the app, they're going to be changing those view codes. And so you get to the end of your 2-week-long process of putting T wraps around everything, and then you merge your branch into master. What happens? Right? You have 500 conflicts, right? Everything conflicts, and it's awful. So what Git allows you to do, because you can do reintegration merges very easily this way, is it allows you to say, create a branch called internationalization, start doing work, and then merge into that branch from master every day, right? And if you merge in every day, you only have conflicts in the last 24 hours. Or if you merge in every 2 days, you only have conflicts since the last time you merged in. Master never gets modified. It never sees anything you're doing, but you're keeping your branch up to date with master, right? And so you get to the end of 2 weeks, and then you switch back to master and merge in i18n, all of the work has been done for you. It simply does a fast forward, which I'll explain in a minute, and it's done, right? You can do everything in a specific context, and you don't have to worry about it, and you just merge in from the one you want to keep up to date on, right? So that is why people like branching and merging, because you can do the fast context switching this way, go back and forth. If I wanted to go back to my email branch, I can still go back, and it just takes out all the blue stuff that I've been working on in the other branch. Yeah. You do fast forward only merges on your main branch. So when you do a merge, LOL is not a command. So this is what the graph looks like, right? It keeps the merge history, which is how it can do the three-way merge, the reintegration merges easily. You don't have to specify merge base because it can figure it out from the graph. But if you want to make sure that you're not doing any merge work in master, you can say, when you say git merge, you can say merge ff only, blue, like that. And it'll make sure that the branch you're merging in if you follow the history of the branch you're merging in, it can reach the branch you're on, right? Which means it's newer. It has merged in the work you're on at some point. And so it will only do fast forward merges, right? If it has diverged in some way, it will not allow you to do that, which means you can't fix, you can't have any merge conflicts. If FF only works, there will be no merge conflicts because it just moves the pointer up the graph.
Okay, but you say not allowed. Is that a policy you can set on master?
No, it has to. Well, you can set the policy on the server if you want to, right? If you own your own Git server, you can put in hooks that enforce that. So that was the demo. So now I'm going to go through some of the stuff that I did in that demo and show you sort of behind the scenes, like what is happening, what is Git doing, right? So the first thing that you want to do if you're using the command line is you want to set your username and email. Like if you're using Eclipse, it'll make you do this when you set up the plugin. But if you're using the command line, there's no central server to authenticate to say these changes I'm introducing are from this user, right? The user database is not on some central server that you authenticate to. So what happens is you tell the system who you are. You write, because all of your changes are being written locally, right? You write all your changes locally, and then you push to the server. And if you have write access, it trusts you, right? That you are who you said you were when you wrote all those things. It doesn't verify this data. Again, you can set up hooks and stuff to verify this data if you want to, but usually it's if you have SSH access to the machine, then you're part of the company and you're trusted to do this sort of thing. You also probably want to set the coloring on so you can get the nice coloring stuff that I have there as well. There's also, if you use a shell and you want to do this sort of stuff, I highly recommend using the bash completion stuff, the shell completion. So there's Z shell and bash and C shell, I think. And it'll do stuff like you can type, like you can say, oops, if I have it on, it'll give you stuff like what branch you're in, right? So if I can figure out what branch I'm in all the time. So now I'm in the master branch because it says in my prompt there. And I can say m tab, and it'll tab complete branches and stuff like that. So it's very nice. OK, so those are the things you want to do. So now, get a repo. So the first thing that I did was I ran git init to create one, right? You can create a repository. You can go, I used to do this in my keynote presentations. I still do sometimes. Go into the .key directory, because in Mac it's a directory, or you can make it be a directory, and just run git init and start version controlling Keynote, right? Where I don't have to do one big massive thing. I can just version control the directory. You can go to any directory, run git init, and just start version controlling that directory, because it's so easy to do. Just run git init and start running git add, git commit, right? You don't have to put it anywhere. You don't have to get somebody to provision it for you. So if you run git init, this is what happens. It creates a .git directory, which you didn't see because it's a .file, right? So it's sort of hidden from a listing. But you can go into it and you can look at it. Right now, when you run git init, it just creates a skeleton. It is not like Subversion. It does not put a .git directory in every subdirectory of your project. It's not metadata. This is your database. If you tar this up and you email it to somebody or you put it on some server, you can untar it, and that is now a node, right? That has all of the data that you need. When you do a clone, this is what comes down. And then we have our file in the directory there. So now we run git add dot, and we commit. Now, the only real difference, if we look in this .git directory again, we see a couple differences. One is, in the objects subdirectory, we have all these objects, right? This is the data. This is the database for Git. It just writes one object. It writes it into a file named the SHA, named the checksum, right? If you open this, which is basically just an unzip, you have to use gzip, there's a little weird header on it, but if you just unzip that file, what you get is the raw data, right? One of them is the file contents for hello world, one of them is the directory listing, the tree, the other one is the commit metadata, who you were, what date you did, what your commit message was, right? The commit message, the commit object points to the tree, and then the tree points to the blob. So if you can get the commit one, you can traverse the pointers to find everything in the database. All the objects are reachable. Does that make sense? How do you find the commit, right? So the way Git finds the commit is through branches, is through these references. So if you go into refs heads, it has all your branches. If you wanted to create a branch that pointed at a specific commit, you could actually say echo and then a SHA and then redirect it into .git/refs heads anything I want, and that will create a branch called anything I want, because all the branches is a pointer to a commit. But this gives us a thing where I can cat that, get a SHA, that will point to the commit, I can open that up, that'll have a pointer to the tree, I can open that up, that'll have a pointer to the blob, and then I've reached all of the objects in my database, right? So this is how Git works on the lowest level. But you don't really need to know that, I just think it's interesting. The other way, the common way to get a Git repository is to run git clone, right? So this will, instead of creating a new one, this will clone an existing one. So it gives you a database that was on some other system and just gives you a node of that, right? A copy of that database. So you say git clone, give it a URL, it'll take, git colon is an unauthenticated URL, so it's almost always read-only. It's very uncommon to have unauthenticated with write access, but it's unauthenticated and it's special to Git. It will use SSH. SSH will basically take any URL that SCP will take. If it's a Git repository on the other end and you say git clone, and you could SCP it, then you can say git clone and it will clone over that repository. It just piggybacks on SSH. So if you can authenticate it as that user over SSH, then you don't have to set up a Git server. It uses SSH. So that's the easiest way to set up a server if you're doing it yourself. There's also HTTP, HTTPS, file : / There's a couple different ones. But what happens is it will give you a specific binary file with just the data that you need for whatever you're pulling down, which in this case is all of the branches, so all of the reachable data in the database. Pulls it down. You can see the total 591 there. That is 591 objects that are coming down in the binary data that I'm getting. So what we did where we added one file and did one commit, that's 3 objects. This is 591. It's still not that big. There's probably only maybe 100 commits in it or something. Probably less. And then it will give us a checkout of whatever the newest thing is. So we have some starting point, right? So it puts it in a directory. We can go in there, start editing stuff, start saying git add and git commit. Interestingly, though, you don't have to do git commit does not write to the server, right? We can go in, we can clone somebody's repository we do not own, we do not have write access to, and just start committing in it, right? Just start working on the project. We can worry about getting it upstream at a later point. Okay, so then you record a snapshot. So the basic workflow for recording a snapshot is you edit files. So if you're cool, you use Vim. Otherwise, you can use anything else, right? You stage the changes with git add. So you say git add, whatever the file path is that says this file, as it looks like on my disk right now, I want to be in my next snapshot that I share with people when I run git commit. You review the changes with git status or git diff. Yes? And you run git commit, it will commit the version of the file when you ran git add. It snapshots it when you say git add. You could actually say, you could say git add on a whole bunch of files and then remove every file in your working directory except your .git directory and run git commit and it will still work. Git commit by default does not look at your working directory at all. Git commit will take anything you've run git add on plus whatever you had originally checked out, because it's just modifying what you had originally checked out, and it commits that as a snapshot, and then you can push that and merge that and things like that. A basicer workflow, if you are so inclined, if you want to work in the Subversion style, is you can just edit stuff and then say git commit -a, and that will stage and commit everything. I don't know what the team provider in Eclipse does, what options it has for these things, but I believe you can do interesting things, actually even easier. The reason why this exists, like why even have git add at all? Like why make you go through that extra step, right? There's actually some cool things you can do with this by having this middle area. One thing you can do is you can say git add -p, which is -patch, or a lot of the GUIs will do this as well, which allows you to stage sections of a file, right? So if you've modified a file and you put a bunch of comments at the top and some business logic changes in the middle of the file, you can say, and you just want to commit the comments, or you want to commit them separately so it's easier for peer review, you can say git add-p, and it will prompt you hunk by hunk. Do you want to stage this part? Yes or no? Do you want to stage this part? Yes or no? And you go through that whole system, and then you say git commit, and whatever you said yes to, that goes into the snapshot, not necessarily what's on your working directory, right? So you can be very specific about saying, here's all my white space changes that you really don't need to peer review that much, and then here are the business logic changes I really need your attention on, right? Instead of having them all in one big commit because you worked all week on it and never committed it. So it allows you to make sort of last-minute decisions, to craft your commits nicely. This will blow that away. If you do git add-p all over the place and then run git commit-a, it will just stage everything and not care what you had done. So be careful with this. Choose one or the other. Okay, so some behind the scenes a little bit. When you run git commit, it's funny. I like to move around when I talk, but I have to be here so you can see me doing this basically the whole talk. So when you say git commit, what happens is it will give you output that looks like this. And what most people's favorite part about Git is this. This is your version number, right? This is the first, however, 7 characters of a 40-character SHA. There is no 1, 2, 3, 4, 5. There's no monotonically increasing version numbers because there's no central authority to delegate them, right? There's no way, when you do a commit and I do a commit, we're basically working on private branches. When we sync them together, it depends on who pushes first, right? And we could push to separate servers and then have somebody else pull those down and merge them together. There's no canonical database that can say 1, 2, 3, 4, 5. And you can see that it branches and merges all over the place like you saw in that graph. So what happens instead is that Git doesn't even try. It doesn't even try. What it does is it writes all those objects, even the commits, as objects named after the SHAs, and then when you synchronize your database, when you push to another database or when you fetch something in, all it does is take every object you don't have yet and throws it into the same namespace because it knows there aren't going to be any collisions, right? So it just adds every object you don't have yet and a couple pointers, so it doesn't have to worry about trying to merge files or anything like that when you actually synchronize databases. Does that make sense? So there's no human readable version of these. You can run git describe on one of these and it'll give you a version of this that is more human readable relative to the last tag that you made, which is kind of nice for going over email and stuff. But it still embeds part of the SHA in it, so it can be non-ambiguous. Yeah. So the question is, there are different operations to compare your local changes from the last thing that you did and your local changes to the server, right? And
new incoming changes from the server that will be.
And new incoming changes from the server. So I'll get to that in the last section if I get to that. But basically, what you have to do is when you fetch, you get the commit chain, the commit history, the chain of commit snapshots that have been created by other people and pushed to that server, and you run git fetch, it will pull them onto your local system, and you can compare the last snapshots in each of those, right? There's nothing that will compare something directly on the server. You have to pull that database into your database and then compare it locally. So there's no difference between comparing something on a remote branch and comparing something on a local branch, because what you do is you make the remote branch local branches and you compare it just like you would compare any of your 2 branches, right? It would be the master, like I want to see the difference between my master branch and the master branch on the server. Or I want to see the difference between my master branch and my blue branch, right? There's no difference between those operations. As far as Git is concerned, everything has to operate locally. So you pull it local, and then you do the comparison locally. Yeah?
So what you're saying, when you do a git clone, you're just getting the master branch history. You have to do an additional git fetch if I want to be able to have all the history that's on that.
No, by default, when you run clone, it will give you every branch that's on the server.
Okay.
It will check out one of them locally so that you have something to work on, but you will have bookmarks to every other one. And so you can compare whatever you've been doing to either what it was based on or to any other branch that came down. And when you do a fetch, by default, it will pull down all of the new branches on the system as well, so that it's easy to collaborate with people. Yeah. So I actually already went over this, and I want to get to the other stuff. So I'm going to go through it kind of quickly. But if you ask it what this is, it will give you raw data back, right? This is the commit data, and it has a pointer to the tree and a pointer to the commit that came before. And if you ask it what that tree is, it will give you back raw data that looks kind of like this, right? Here are the files and all of the contents that those files are. And if you ask it for the parent, it will give you another commit object and so on and so forth, right? So this is how Git keeps its data. It's just a series, a directed graph of snapshots. So when you say git checkout, it actually pulls all that into a file called the index and then from there into your working directory so you can actually modify it. And then you modify the files, and then you run git add, and it will checksum them and overwrite the entry in the index. And then when you run git commit, it only operates on the index. So this is why if you delete all of these and you run git commit, it doesn't care, because it already has all the data it needs in the repository and in the index, and it will just create the commits and trees that it needs to fulfill that. All the blobs happen when you run git add, and we'll add them to the database. So it doesn't really care what's in the working directory necessarily. Okay, so branching and merging. So given that, branches are pointers into this graph. So I showed you the graph before in my history, right? If we look at this, oops, we can see this graph, right? Master's at the top, and then its parents are blue and whatever came before on master, and then its parents are blue background and what is now the email branch. But you can go through the history. The pointers, the branches are, you can see it designated here, email, blue, master. They're simply pointers into this graph, right? This is the farthest place that master is right now. This is the farthest place that blue is. It can go off in different directions, right, if you wanted to. If I undid this, blue would be sort of off by itself. You can have different heads, right? So a branch is just a pointer. It's just a reference into that history, into your database somewhere. And they're easy to move and they're lightweight. So the way that you branch is you say git branch will list your branches, will create new branches, and checkout will switch between them, right? So you say check out this branch, and it'll switch the current branch that you're on. So let's say that we have this commit, and by default git init will create a master branch. So you will almost always see master branches in repositories because it's the default, and most people in the entire world are too lazy to change defaults, right? So that's why almost everybody has a master branch. It's not really necessary. It's just another pointer. And then the last concept of git is head. So you'll see head every once in a while. And what head is your current branch. It is a symbolic reference. It's a reference to a branch, right? So you always have head, but head will be pointing to one of these other pointers, to one of the branches that you're on. And it means it is the parent of your next commit. It is what should be checked out into your what was last checked out into your working directory. So anything that you're doing could be comparable to this. This is your last known state of what your working directory was, right? So if you say git branch i18n, if we want to do internationalization on our app, we can say git branch i18n. I did checkout-b, I'll show that in a second. But what all that does is it drops in a pointer, right? If you say git branch something, it will take no time at all because all it's doing is writing 41 bytes to a file and then stopping. It's just creating a pointer on your system. Now, if we run git branch, you can see I did this earlier. It lists out the branches we're on, and it puts a little star next to where head is, right? This is our current branch. This is our current context we're working in. If we look in the refs file, if we actually cat one of these files, we can see it's just the SHA. So it's a fairly simple system. Now, if we check out i18n, what that does is that moves head over to point to i18n instead. And if necessary, it makes your working directory look like whatever i18n points at, right? When you say git checkout i18n, it checks out that into your working directory. That's why it's called checkout. The branch switch is actually sort of a secondary function, but it makes it look like that. In this case, they're both pointing at the same thing, so it's a no-op. It doesn't really do anything, right? If they were in different places, it would make your working directory look like whatever you were switching to. This is important in a second. So if we commit, it writes the new data in. The parent of the new commit snapshot points at whatever head is currently pointing at. So whatever head is at, that is going to be the parent of your next commit. And it moves whatever head's pointing at forward. The only branches that move are the ones that head points at, right? If you are ever scared about doing something in Git, the easiest thing to do is drop a pointer, just say git branch where I was, do whatever the hell you want, and as long as you don't have where I was checked out, it's impossible to lose what that last commit was. Does that make sense? Because it will never move pointers other than what head is pointing at. So you can just throw random pointers in your database if you want to have some place you can get back to easily. So you commit, it moves that branch pointer up. You say checkout-b issue 53 master. So this is a little more complex command. All this is doing is it's creating a branch at a previous point. So it's creating a branch called issue 53 at master and then checking it out immediately. So it does this. This is equivalent to this. I could check out master and then check out -b issue 53, which would create one and switch to it. Or I could do all three of these. Check out master, create the branch, check out the branch, right? All of these are equivalent. Most people like check out -b because usually when you create a branch, you want to switch to it. You're creating it because you want to work in that context. So we commit, right? It goes off in a different direction, right? It writes to the same database, just goes off in a different direction, and we have all these pointers. So now, we can see what Git sees. If you say what happened, if you say git log -- stat or something to see what all the files were changed in each commit, what it's doing is it's just comparing. We can see it, right? From our initial manifest to the second one, we added a file. We didn't change any of the other ones. It can tell really fast because it's just comparing the checksums, right? And then the second one just changed that issue.c file that was introduced. The second branch, the itn branch, adds a new file, modifies that file in the second commit, but also modifies the hello.c file, right? So we know what Git knows at this point. So merging, this is why merging in Git is fairly easy, because what it does when you run git merge is you check out the branch you want to merge, you want to modify, you want to merge into. So we want to modify the master branch. We want to update it to have this new work. So you say check out master, merge whichever branch you want, right? All of these commands are very simple. They usually just take one argument, which is the branch you want to do something with. Check out, branch, merge, they just take one. So I want to merge in issue 53. So it does a calculation. It says, is the commit I'm merging into reachable from the one I'm merging in? Because if so, what I want to end up with, like if you think about this, I added a new file, issue.c, and then I modified it, right? If I merge in that context, what do I want my master branch to look like then? What's that? Yeah, issues. You want it to look like issue 53, like that same snapshot, right? It's not going to be any different. So what it does is the easiest possible thing, which is called a fast forward. It just takes that pointer and moves it up. It doesn't create any new data in the database because it doesn't need any new snapshots. Does that make sense? Now, if I say git merge itn at this point, they are not. One is not reachable from the other, right? And so it's going to do a non-fast forward merge. It has to create a new tree. It has to create a tree that has issue.c and itn.c in it, right? That's what I want. I want both of those contexts together. So I need a new tree. So what Git will do is it will walk through the histories, find the first common best merge base. Some commit it can use as a merge base, and it will use that in a three-way merge as the merge base. So if it needs to figure out something. So in this case, it can see just by looking at these, hello.c is different, right? And so if it doesn't have a merge base, it would have to try and merge them together. But in this case, we can go down to the merge base. We can see hello.c is the same on one side as it is in the merge base. So it didn't care about that file. So all it does is choose this side. It chooses the side that changed, right? It will only make you try and resolve conflicts. It will only possibly have conflicts if the file changed on both sides of the branching. And so it just takes the two new files, because there's no conflict there, slaps them in there, chooses the one side, and you have no merge problems. Not even the possibility of merge problems in this. It's a trivial merge, right? And you didn't have to calculate the merge base or anything like that. Git does all of that for you and will continuously do that for you. So it's very nice. And then moves master up, and now master's there, and we can go back to any of our older contexts if we want to. OK, so that's merging. That's how merging works. If you do get a merge conflict, which is both sides of the merge change the same file in the same hunk, right? And so it cannot merge it together. I mean, you can have, so what it will do is it will put in merge conflict markers, and it will stop. It will not do that final commit for you and create that commit data with the new tree. It will stop, and you can run git status and see what files are still unmerged, right? Or if you add the same name file to both sides, it will do this and give you A and B, and you have to manually merge them together. If you open up the file, it just gives you Subversion merge conflict markers, just sort of standard ones. That way you can run, if you say git mergetool, it will open up a visual merge tool if you want to use Araxis or kdiff3 or emerge or vimdiff or perforce or anything like that, right? Any of those will work to help you solve these conflicts if you want to, or you can just go in and do them by hand.
So Scott, you've got up to 45 minutes.
Oh, really? Yeah. Oh, you guys are going to be here a while. I'm just kidding. OK, so when you've finished the conflict, when you've solved the conflict, the way you mark it as resolved is, again, you run git add, because what you're saying is, I want the content as it looks like right now to go into my next commit, which is going to be the merge commit, right? So you use git add for resolving as well. Git add is used all over the place, but really it has the same semantic context, which is, I want what it looks like right now to be in my next commit. Yes? OK, and then merge tool will fire up any of these, kdiff3, tkdiff, blah, blah, blah. There's a whole bunch of them. And allow you to do it through a graphical context if you want to. And then at the end, you run git commit to finalize the merge commit, the merge, right? So it's a little bit, it's not super intuitive, unfortunately, but it's not difficult to do, right? So you run git status to see what's left. You can also, there's also other cool things. You can say git log and then one of the conflicted files, and it will show you the commits that modified that file in the two sides, the two commits that introduce the changes that are now conflicting, which is actually kind of cool. Yes? Nope. If there's no conflict, it will automatically do the commit. You can say git merge -- no commit, and it will stop. It will just do the merge of any kind, and it will stop before it so you can modify stuff or change the message or something, because it does an auto-generated message for the merge commit. Yeah. Yeah, if you say git commit and then like a message and then a list of file names or one file name, it will automatically add those and then commit them. But it's fairly rare to do that, unless you did a lot in Subversion and it's just carried over. Yeah, you can do git commit -a, and that will automatically stay. Or you can say git add -A, that will add like every file that it sees. Or git add -u will do what commit -a would do, but then not actually do the commit. It's just the add portion of that. So git add has some options to make some of the things easier. There's a ton of options. I just, the important point is that there's 3 different sections. There's your working directory, which git commit doesn't normally care about, your index, your staging area that you have to stage stuff in with git add, and then git commit looks at that, and then head moves to whatever you did when you run git commit, right? Head updates as you do that. Okay, so reintegration merges, I already sort of talked about this, but we can easily go back to one of our branches, commit to that branch, and then go back to master and merge it again. And the reason why it's easy to do reintegration merges is because we don't have to figure out the merge base again. It's not a complex operation, right? Since you can see the merge commit keeps pointers to both parents that it merged together. When we go and try and find a good merge base, it can follow both pointers, right? The same commit is still a common commit, right? The first commit is still a common commit like it was in the last merge, but also a common commit is 3acd1 over here, right? So it sees that as a better candidate, and it uses that as the merge base. And so when it's merging, it doesn't have to go all the way back. It just simply sees what the difference is since the last merge, and it uses that, right? So you can continuously merge in from branches, and it will try to figure out the best merge base to do with that, and it's generally fairly simple. Okay, so some of the reasons why I think branching is cool, just real fast, I kind of went over them already, but the reintegration merge thing is really cool, but you can use it in several different ways, right? You can use it to try out an idea. You can create a branch, work on it, and then if it doesn't work out, go back to master and just delete the branch, right? It's very easy to do that. Or you can isolate work units. So you can have a branch for every ticket that you're working. If you're working in Bugzilla or something, a branch, issue 53, issue 86, issue 102, and switch back and forth them as you're working on them in parallel, right? Or leave one there for a week or 2, and then come back to it and update it and start working on it again. It's very easy to do that, right? So isolating your work units is nice. Instead of doing like feature flag development, right? Where you're like, don't turn this functionality on until I want it to go live or something like that, right? What you do is you keep it in a branch, and maybe you keep it updated with a master branch, and then when you're ready, you simply merge it in the master branch, and it does a fast forward, right? If you do, yeah. And then the final thing you can do is long-running topics. So all of these things, which are really very different things, are all managed by a very simple system, which is create a branch with a certain name, check out the branch, back and forth, merge the branch, right? There's no complicated options to these that you need to use, right? They're all very, very simple. Deleting branches, you can say branch -d, and with lowercase d, it's safe. It walks the history, makes sure that that branch is in the history, is reachable from where your current head is. And if it is, it will just remove the pointer. If it's not, then that means it might have unique work on it, so it will not delete it by default. So there's a safety mechanism in lowercase d. If you just want to get rid of it, if it was a bad idea and you're like, if anybody in my company sees this, I'll be fired because that was really stupid, you just hit -D, it will remove the pointer. The data will still be in your database, but it's not reachable by anything. So it'd be very difficult for someone else to see. It's not going to be pushed ever, right? Okay, so pushing. So this is the last section. This is remotes. So now all of the stuff that we've done except for clone so far has been entirely local. All of these things you can perfectly do them without ever hitting the network at all, without even having an Ethernet card in your, who uses Ethernet anymore? Without having a wireless card in your computer. So Git does not have the concept of a server, right? It does not have the concept of a central server. What it has is the concept of remotes, which are, here are URLs of any kind to other databases, other nodes of this project that I know about. And it doesn't actually necessarily need to even be of that project. You could have it point to any other Git repository, though that gets kind of weird, so don't do it. But you can basically say, here's another URL that is of this project. It's some meaningful node. It can be my friend's computer, so I can fetch from his stuff, right? If I just want to fetch directly from them. It can be, a bunch of different people that you're working with, whatever. You don't have to have any, or you can have 100. It doesn't really matter. It can be the staging server. It can be you push to deploy, whatever. So the concept of that is a remote, and it's really just an alias for a URL. So if you clone, so let's say we have a Git repository on our server, on our company server somewhere, and it has 2 commits and a master branch. When you clone, you get the database. You get all the same objects that the database that database has. You get it locally, and you get 2 things. One is you get all of the branches on the server. So in this case, they have master, so we get origin/master. When you do a clone, it creates a remote for you automatically called origin by default. You can name it something different. You can delete it immediately if you want to. It doesn't really matter. But it gives you a point of this is where you got this data from initially if you did a clone. If you do an init, you will not have an origin. If you did a clone, you'll have an origin slash, and then every branch, right? Origin/master, origin/this. That's how it namespaces it so that your branches don't interfere with those branches, which was an earlier question, right? All of the branches on that server are origin/whatever. If I add Nick individual as a friend, and I just want to see what he's working on, I can add him as a remote if I have read access to his repository. I can add him as a remote named Nick, run fetch, and then I have Nick/master, right? And so I can see the difference between my master, Nick/master, origin/master, okay? So that's what origin/master, and then usually it'll give you a branch by default that you can start working in. So usually it's named after whatever the head on the server is. You designate one of, the server has a head as well. That is the main branch of that server. So you get an equivalent of it. Now, Scott clones the same thing, gets exactly the same thing. So now there's 3 versions of this database sitting around. Now, if I commit, I create some awesome feature. It just goes into my database. I've done 2 commits here, right? Nick does a couple of commits, adds his awesome feature, right? We're all working on our own master branches, and I can see if I do a diff or if I do a log, like what's the difference between origin master and master, I can see just my 2 commits, right? What have I done since? I can compare those branches. Now, git push is how you share changes with a system, with another server. And what it means is if you say git push origin master, what it says is it's git push and then a server or an alias. You could put the whole URL again if you wanted to, but usually it's easier if you have an alias to just write the alias name. And then what branch you want to update on that system. So in this case, what this is going to try to do is communicate with the server and say, I want the master branch on the origin server to be the exact same as the master branch on my server, or in my database. I want them to point to the exact same place. That's all it does. It does not do merges on the server at all. It does not do any. If you modify a file and Nick modifies a file and you both try and push, but they're different files, it will stop the second pusher, right? It will not try and do any work on the system. All it does is this. Contacts this server and says, I want to make your branch name this, my branch name this. If you want it to be different, you can do a colon. I want my master branch to be master colon, Scott. I will make my master branch a branch named Scott. I'm trying to update a branch named Scott on the system. So the conversation goes like this. I want to push some stuff. Server says, here are the list of the branches I have and what they point to. Your client walks through the history of what you're trying to push and says, cool, I can see that. So it would be a fast forward merge if I were to try and merge it. So since I can see it in my history, I will update it on the server. So it takes the difference, just transfers the difference. Once that's in place and everything's good, it moves the pointer. So now the master branch on the server is pointing at the exact same commit as the master branch locally. That is all push will ever do. Okay? So when it gets more complicated is now when Nick tries to push. He wants to get his changes up there as well. So the conversation goes like this. It's the same conversation basically. Nick says, I want to push some stuff. It says, I've got master at 9005. Nick walks through his whole history, reaches every commit he has in his whole history of what he's trying to push up, and does not see that, right? It's not that it's not in his database. Maybe it's in his database, but he's abandoned it or rebased or rewritten history or something. It's that he cannot see it in the history of the branch he's pushing up if he walks all the parents. And so since he can't see it, if he were to update it, what would it do, right? If he were to push, if he were to force this push, what it would do is it would make master on the server point to 8091. It would effectively abandon, it would do a non-fast forward, it would do a branch change, right? It would just switch the master branch on the server over to something different. It would abandon those objects on the system, and then when Scott fetched, it would look weird, right? Because it wouldn't have his old data in it. So since that would be mean, technically you can do that, but don't do it. Since that would be mean, your client will refuse to do it, right? It will say your push is rejected, and don't take that personally. It has nothing to do with you as a person. It just says if you were to do it, you would be abandoning people's changes on the server. So what you have to do is this. You have to fetch down. So now Nick will say git fetch, pull down the difference, and now I have origin/master at the same point that the master branch and the origin is. And then I can merge them like I can merge any other branch, right? So I say git merge origin/master or origin/whatever. And that will merge that branch in. And now when I push, right, if I do the same thing, git push origin master, all right, I want to do it again. Well, I haven't changed, right? Master's at 9805. Awesome. I can see that somewhere in the history of what I'm trying to update. And so it puts the difference up and then moves the branch. And then that way, by rejecting things that aren't contained in what you're pushing, it makes you not overwrite stuff without having it be very complex on the server, right? The server logic is very, very simple. So that's how pushing works. Now, if you want to push another branch, if I had some other branch over here, issue 53, that had gone off in a different direction, and I want to work with Nick on this branch, but I don't want to commit it to master, right? I don't want to be working on master to collaborate. I want to work with Nick on a different branch. It doesn't matter. Master is not special in any way, so I can just as easily push that branch up as well. So I just say git push origin issue 53. I want a branch named issue 53 on the server that is pointing exactly where mine is, which is the same thing you would do if you were to push an existing branch, to update a branch, right? It's saying I want a master branch that points at wherever my master branch is. If it exists, it does the check. If it doesn't, it simply says, here are all the branches I have. I don't see the branch I'm trying to push, so I'm not going to be losing anything, so I'll just do it, right? The server will simply accept it. And so it just copies the difference, creates a new branch on the server, and now when Nick fetches, he will get all of the branches on the server by default. That's what clone will set up a fetch spec that looks like, just give me everything on the server when you do a fetch. And now I have origin/issue53. So now Nick, if he wanted to work with me on it, could create a branch there, start working on it, git push issue 53, I fetch it down, merge it in with mine, work on it, git push issue 53, and so we can just work on that and ignore master if we wanted to do that. Does that make sense? Okay, so that's how Git works. Pull, if anybody's used pull, is a wrapper script. It simply does, Git can have this context of, or this concept of what are called tracking branches, which is a mapping between a local branch and a branch on a specific server. So when you're on that branch and you say git pull, what it will do is do the fetch of that branch from that server, pull it down, and then automatically try and merge it in. So this makes it a little bit easier if you're always working on the master branch. This simplifies things because if you do a push and it says rejected, you say pull, it will fetch it down, merge it, and then you say push again immediately, right? Or fix any problems that there were. All the merges happen locally, but this makes it easier. If you have lots of branches that you're working on, this can often confuse people because generally when you do a push, it will not set up that branch to track. So when you do a pull and you're on a branch that is not tracking, it will do a fetch and give you the normal fetch output and then blow up with like this huge thing that's like, I don't know what's happening, I don't know what to merge in or what to do, and it has like these huge things. It's like your fetch spec is off and there's sideband errors and demultiplexer, and you're like, what the fuck is happening? So what you do, what I like to do is not deal with that, just not worry about tracking branches. It's usually easier to do what I say, to just do the fetch, do the merge, make sure that you're on the right branch, you're merging in the right branch, right? Take 3 extra seconds, do it manually, and then push it up again, and just deal with push and fetch, and that's it. Right, and do the merges manually. Because you're doing what you're telling it to do. It's not trying to infer stuff, right, which really confuses people a lot of times. Unless you are very comfortable with the concept of tracking branches, I would stay away from git pull. But all it is a fetch and a merge. Okay, so I want to get to one more thing. I think I've done the remotes enough, so I'm going to do the fastest version of this I've ever done. So if we have 2 files, 1 commit, we'll have 4 objects, right? The 2 contents, 1 tree, the 1 commit. So that's what we have. If I push it to a server, I can push it to my own server that I have write access to, but it's public. I have given everybody read access to, right? And then I want to work with people on it. So Nick clones it, gets the same object. Jessica clones it, gets the same objects, does a commit. They both push to theirs that have the same property. Everybody can read it, but only they can write to it, right? And then they email me and say, here's the URL that has feature A. I can add him as a remote. I can add Jess as a remote. I can fetch Nick, pulls down his stuff. I get Nick/master. I can fetch Jess, pull down her stuff, I get Jess/master, I can merge them all together to update my master and push up, and then they can fetch from that to get each other's work, and that will scale out to thousands of developers, right? This is sort of how the Linux kernel does it, where you don't deal with 10,000 developers, you deal with your sub-project, right? And everybody, you have write access to yours and read access to everybody else's, and you can have this sort of hierarchy, right? This distributed system. So this is how GitHub works, right? There's a forking thing where you fork it, you get your own writable thing. It's very uncommon to have like commit bits in projects where you're saying you're the core team that can commit to this open source project, because what is far more often is you have one or two maintainers and then they just have trusted people that they pull from all the time and don't really check the merges as much because they're trusted, right? That is a commit bit, is for the maintainer to trust them. So that's where all the objects have been. OK, so that's multiple remotes. So the last thing I want to do, git log. Git log walks your commit history, so you can actually look at this history. So when you saw before I did this, git lol, that is an alias, and I'll show you what that does right now. So if you say git log, what it will assume, it's exactly the same as git log head, right? It assumes this is my starting point, and I'm going to walk the history, show you every commit I can reach from head down. So it walks it, master, head points to master, master points to this. So I'm going to start walking those. These are all the commits that are reachable. So I'm going to show it to you in a flattened format like this. This is all of the commits that have worked together to get to this point to have the snapshot you now have in your working directory. And you can see all of the data, right? Side A, side B, it just flattens them together. And then for each one, it has the full commit SHA, the author, the date, and the message. You can also format this, though, and this is really interesting for doing things like change logs, like not change logs that you'd put in a thing generally, but like what is the difference between these two branches in the most simple format. So you can say -- one line, it'll give you the same data, but just much simpler, right? Not all of the metadata, just here's all the first lines of all the commit messages. You can give it a different starting point. One line issue 53, what are all the commits on issue 53? Here's the 3, here are their commit messages. Here's a different starting point. You can say -- graph. This is a cute way of seeing a graph in ASCII on a command line. Most of you will be using a GUI probably, and it will just show you this in GUI form. Actually, most of this will just you can do on the GUI. But if you're using the command line, there's some cool stuff you can do with this. But the important part, blah, 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 all and decorate. So this is what you're seeing when I say LOL, is it's running one line, graph, decorate, right? And so I get this sort of nice thing. So I don't have to fire up a GUI every time I want to see what the graph looks like. And then it has, here's where all of my pointers are. So this is what I have set up. You can set up aliases. If you're finding, like I was saying, no FF or FF only for merges, if you want to set that up as a thing that you do all the time, you can set up an alias where you say git FF merge, and you have it expand to merge -- FF only or something. Or if you have something really long like this you don't want to type out every time, you can set up an alias fairly easily and run that. OK, so this is the last thing. This is very important because it's fairly difficult to learn unless you like read a book or come to a talk, and I'm usually the only person talking about this sort of stuff. But log subsets. So because it's a graph, you can do graph operations on it, right? Which are interesting, which are meaningful. So if you do this, some of you will see this as branch B .. branch A. That's another way of doing this exact same thing. I like this because you can put multiple arguments on the command line, and it's easier for my brain to parse. But what this means is, show me every commit reachable by branch A that is not reachable by branch B, right? And so what that is the difference. It's the reachability difference between the two. What is every commit that's reachable from one that has been merged into one that has not been merged in together? And so you can do stuff like this, right? What is in issue 53 that's not yet in I18N, that I have not merged into I18N, right? So you can say, here's issue 53, everything reachable. Here's I18N, everything reachable. That's the difference. That is what is unique to issue 53 relative to I18N, right? Does that make sense? So now, if you say git log, it will just show you those two. So that gives you a nice difference, right? So what is in my topic branch that I haven't merged into master? You'll want to ask this all the time. Here's a whole bunch of branches I have. What is unique to them? Is there anything unique to them? Can I just delete them without losing any data, right? So you can say, what's in I18N that's not in master? Here's everything reachable by I18N. Here's everything reachable by master. That's the difference. This is the one commit that's unique to the branch. If I were to delete it, that is the commit I would lose, right? If I were to merge it, that's the commit that would come in. So that's interesting, right? Because that is what that branch represents. I'm surprised more GUIs don't make it easy to do this, because it's the most useful thing in Git to me, right? What does this branch mean? So here's a quiz. And if you are a large or an extra large, I have a t-shirt for you that is this beautiful t-shirt right here. So I'm going to do extra large first. So only extra large people can answer this. What does this do? This is effectively Git incoming, right? If you do a fetch and then you run this, you have to do the fetch because the log will not look at a remote. But if you do a fetch and then you run this will show you the equivalent of Git incoming, right? What is on the master branch I just pulled down that I have not merged into my own master branch yet, or whatever branches you're interested in. But this is incoming. What is on the server that I just synced down that I do not have in my working context right now? Now, only large people can answer this. Really, way in the back. What's up?
It's the opposite of that.
I'm gonna take somebody else now. No, wait. Can you? What question would you answer?
Show me all of the things that I have on my local system that have not yet been put onto Origin.
Perfect. Ooh. That is Git outgoing, right? These are all of the commits that you've committed that you have not pushed to the server yet, because this does not update until you can't check out Origin master. It will not allow you to do it, because the point of it is so that you know where these branches are on these remotes. So this is outgoing. If I run git push, this is what will go up. This is what I will share with people, right? Now, if you merge Origin master into master, this will cease to give you output, but this still will, right? It will give you the exact same output, even though you merged an Origin master into it, because it's still, these commits are still not in Origin master. This ceases to give you output when you do the push. Does that make sense? But the same thing can be applied to any branches in your system. What is in this branch that's not in this branch? What is the sum total of all of the unique commits across these 3 branches that are not in either of these 2 branches, right? You can do not this, not that. It works just fine. Yeah? No. None of these run, nothing that log does goes over the network. This is cached. This is after fetch. Yes? It does a log, so whatever log output looks like normally. It just restricts the output of the log to just this set. So
Right, but it's not going to give you file diffs.
it can. So that's a lot. Those are log options. So if you say git log, it gives you the log. If you say git log -p, it'll give you the patch introduced in each one. If you say log --stat, it will give you the files change. You can see public index on that second one. And you can also do no merges. So here's the index was changed there, index was changed. This is not really that helpful. So for each commit, I can see what files were changed and what's the sort of general change was. And if I want to see the actual patch, I can do -p. But any of these so here's the actual patch, right? So any of these restrictions, any of this branch, not this branch, take all of these options. So I can see basically a list of patches that I haven't pushed yet. If I say log master not origin master -p, right? That's a list of patches, and vice versa. Okay, so that's it. These are the commands that I introduced. Not really going to go over them because I've gone far enough. But these are all. I did 12 commands, right? This is not ridiculous, right? This 12 verbs. This does 99% of everything you're probably ever going to do in Git. This is your day-to-day workflow, and there's a couple options to some of these, and gitref.org will tell you what the useful ones that I think are useful are, including this branch, not this branch syntax, if you want to review any of them. But that's it. That's basic Git. So those 12 commands. So I'll take questions. There's stickers here, and thank you very much. Yeah, so the question is, Git pulls down snapshots, not deltas, so do you have to deal with a lot of branches you don't want to deal with? So sort of, if you say git branch, I mean, it depends on your UI, right? So I use the command line most of the time. It depends on your UI. Here are all of the, sorry about that. Here are all of the branches I'm currently working on. I can delete them or whatever. If I say remote or branch -r, I get all of them, right? So here are all of the ones on the server as well. So that can be sort of overwhelming. But generally, I don't like look through them, right? So I know the context that I need to be interested in to work on whatever I'm working on, and it tends to be fairly easy to parse them. As far as like space things with snapshots, not deltas, it actually does pull down a pack file that's all deltafied. And so it pulls down, in general, much faster and much less than Subversion does. Even clones are, I've seen a clone of a similar project take more time in Subversion with a checkout, where you're just getting the last version because it's so over HTTP because it's so bad, versus Git, which is very, very efficient at it. Yeah. So the common so there's a multi-part question. How do I convince my boss to use it, if we're not, and how do I? So it depends on your boss, right? How you convince them and how big your team is and stuff. So what are the objections? There used to be GUI support. There used to not be very good GUI support for it. If you're a Java developer and you're using Eclipse, Git GUI or eGit plugin will be shipping with Indigo, I think. Will be actually shipping with Indigo. And it is very good now. It was not very good a year ago. So eGit, yeah, Eclipse Git, the Eclipse Git plugin. So GUI support is getting a lot better. There's GUIs for Macs that are nice that you can pay for. There's a number of them. There's GUIs for Windows. There's shell extensions and stuff. So what's that? The IDEA, almost all IntelliJ, IDEA. A lot of the IDEs have good plugins now. So that is becoming less so. That was more a year ago. How you convince them, I don't know. I put up a website called whygit-is-better-than-x.com where I summarized the sort of high-end stuff. It's not here's fair on side A and fair on side B. It's very biased towards Git, but it's a good summary, right? Of these are the arguments. So there's that, or you can sometimes it works to list out companies that are using it. So like Android is using it, right? So if Android can do it in a company that big, then and so Motorola and Qualcomm and all these companies are using it because they are, and they're seeing ClearCase actually sucks. Why are we doing this and paying money for it? So a lot of them are switching over to Git. So sometimes that works. It really depends. Yeah. Yeah. So can you use SVN with, or can you use Git as a SVN client? I think is sort of the question. And there is, for more data on, or for more information on this, there is Git another system. So there's a Git and Subversion section on here, but there's a tool that comes with. It's actually a really good bridge called Git SVN. I mean, compared to SCM bridges go, it's one of the best ones. Which is not, I mean, it still has to work with Subversion, so it still has the limitations of Subversion. This points out a lot of problems you can run into. But basically, you say, git svn clone or git svn checkout, I think, and then it pulls it down. You say git svn decommit, and it will commit to the Subversion server, but you can do all your local stuff in Git. I think that was it. So if you have any other questions, come up. I'll still be here for a couple minutes, so thanks.